Okay, the first observation I'm going to make here is that we're interpreting this, what looks like a V, as a square root symbol, square root of x. So one of the graphs is y equals x cubed, which is this red curve, and the other is y equals x to the 1/2, or the square root of x, which is this blue curve. And the other observation, real quickly, is that k has to be on the interval 0 to 1/2, so right away we can reject this value for c, even though it's pictured up here. So these black lines represent the multiple choice possibilities. So these black lines are actually the side of a square. You have to visualize the square coming in 3 dimensions up out of this xy plane. And an expression that represents the length of the side of the square is the y coordinate at the top, x to the 1/2, minus the y coordinate at the bottom, x cubed. So there is the length of the side of the square for each x between 0 and these two curves intersect at the point 1, 1. So the area of the square is the side squared. And if I expand that out using FOIL, there's an expression for the volume, the area of a square, which I've called a sub x. A of x, there you go. So the volume of that three-dimensional solid by slicing is the definite integral from 0 to 1 of a of x dx. So I need an antiderivative for a of x, which is what this is, evaluated from 0 to 1, which means I'm putting 1 in for x, and then subtracting, putting 0 in for x. That's this number right here. So the volume of this entire region from 0 to 1 is 25,126. And we want to find the value of k that will be a third of that. So a third of that is 1/3 times 25,126 is, there's a third of the entire volume. And so I want to know, when does, if you picture putting the definite integral from 0 to k of a of x dx, this is what you get right here. And we want to know, when does that equal 25,378? So we have to solve this equation for k. How can we do that? Well, not algebraically. There's probably two choices. Think of this as a function right here. Graph it on a graphing system, and then graph y equals 25,378 and see where those two curves intersect. The other option is to use Newton's method. I'll take us to board 2 and you can take a look. Here's Newton's method. Here's f of x, where we've brought the 25,378 over to be part of the function. And then we'll use Newton's method, which is this expression right here. Start at point 3, and there is the value of k that will give us a volume that's 1/3 of the entire volume. The other way, here's the function, this red curve. Here's the line y equals 25,378. They intersect at 0.37837. Okay, there you go. Hope that helped. If you have any questions, post a comment.